We all know that manganese is only the element which shows the +7 oxidation state, and that too it is the maximum in the 3D series. The d orbitals which is completely filled. In which element? In the zinc, cadmium as well as in the mercury. Interstitial means vacant site in the metal are get trapped by the some of the smaller atoms. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the Unit 8, the D and F block elements. Before going to discuss with this unit, let's see the weightage of this unit. From this unit, we can expect one 1-mark question and three 3-mark questions. And you can see that the question number 10, question number 30, 31, 32 will come from this unit, and totally we can expect the 10 marks by this unit. Okay, we will see how the 1-mark question will be raised in the D and F block element, and how in the 3 marks the question will be arises, will understand in this session. Okay, coming into the 1-mark question, most of the questions it will be based upon the 3D series of the transition elements. Okay, name one 3D transition element that do not shows variable oxidation state. So we all know that the 3D transition element is a scandium which do not show the variable oxidation state because it shows the +3 oxidation state. Coming into the next question, name the 3D series metal which shows the highest oxidation state. We all know that manganese is only the element which shows the +7 oxidation state, and that too it is the maximum in the 3D series. Next question, name the metal in the 3D transition metal which exhibit the +1 oxidation state more frequently. We all know that the copper is only the metal more frequently it exhibits in a +1 oxidation state as well as in a +2 oxidation state. Between these two states, the +1 is more frequently exhibited by the copper. Next, name the alloy of the transition metal with the non-transition metal. So we have the alloys like bronze and bronze. You can see that how this alloy which also metal with the non-transition metal. Coming into the next question, what is the action of neutral or fairly alkaline paramanganate solution on iodide? We all know that alkaline potassium paramanganate solution oxidizes the iodide to the iodate. So it oxidizes the iodide to the iodide. Okay. Next question. Zinc, cadmium and mercury of the group 12 are not regarded as a transition metal. Why? You need to say the reason for this. Zinc, cadmium and mercury of the group 12 have full D10 configurations, which means to say that their d orbitals which is completely filled. In which element? In the zinc, cadmium as well as in the mercury. So that their ground state as well as in the common oxidation state, hence they are regarded as a transition element. In the ground state as well as in their transition state, or in the excited state, if you see them, they shows a completely filled D10 orbitals in the d orbital. So that is why they are known as what? Transition metals. Next question. Transition metals exhibit variable oxidation state in its compound. Why? You need to say the reason for this. We know that transition metal exhibit the variable oxidation state in its compound form due to the availability of Ns and N- d electron for the bonding. If you see the 3D series, 4D series, 5D series and 6D series, they are together known as what? D block elements. In all this series of elements, there is the availability of a Ns and N-1. which means to say that the last electrons which is going to add to the inner shells, that to the penultimate shell. Correct, no? Hence, due to the availability of the inner shell, and to that, it is added to the d orbital. That is why, in its compound form, they are known as what? Transition metal, and that too, it exhibits a variable oxidation state. Give one use of mesh metal. The mesh metal will be used in magnesium-based alloy to produce the bullet shells and the light faint. Okay, these are the more frequently asked questions in the 1 mark part. We'll see with the 3 mark, because from this unit there is no 5 mark question at all. So we'll see with the 3 marks directly. Mention any 2 consequences of lanthanide contraction. So in this part, lanthanide contraction, what are the consequences of lanthanide contraction, and also with the causes of lanthanide contraction, differences between lanthanide and actinides, and also with the catalytic properties of the transition series, and that are more frequently asked question in the 3 marks. Okay, we'll see how to write it for the answer. The radii of the 3D row transition series of the elements are almost the same than that of the second row transition series of the element, or you can write they have a identical radii of the zirconium as well as with the osmium. So for the 1 mark also, they can ask you why zirconium as well as with osmium, they shows almost the same atomic radii due to the lanthanide contraction. Okay. Next, the separation of lanthanide in a pure state are become very difficult. These are the main 2 consequences of the lanthanide contraction. Next question. What is lanthanide contraction? Mention the cause for the lanthanide contraction. Writing the correct statement with 1 causes, you will get a 3 marks. Okay. We know that lanthanide contraction is nothing but a decreasing in atomic radii or ionic radii from lanthanum to lutetium. So if you see that the lanthanide series, that is the F block elements in the periodic table. So from lanthanum to lutetium, there is a decreasing in atomic radii will be observed. So this decreasing in atomic radii from lanthanum to lutetium, it is said to be lanthanide contraction, and the cause for is the majorly with the similar physical and chemical property. Next question. What are interstitial compounds? Give an example. Interstitial compounds are those which are formed by small atoms like carbon and hydrogen are trapped inside the crystal lattice of the metals. So if you consider any metal, I'll go with the titanium metal. So in the titanium metal, if some of the vacancy, if it is has been created, this vacancy will be get trapped by the some of the small atoms like hydrogen, carbon as well as with a nitrogen. So if this vacant site or the interstitial sites are get occupied by some of the smaller atom, such compounds are said to be interstitial compound. The example is titan with the carbon, manganese with the carbon, nitrogen as well as with the iron with the hydrogen. You can see that carbon, nitrogen and hydrogen are the 3 small elements which are get trapped at the interstitial sites of the or vacant sites of the metal atom. Thereby it create the interstitial compound. Hence the name it is given as interstitial compound. Interstitial means vacant site in the metal are get trapped by the some of the smaller atoms. Okay. Next question. Between titanium plus 4 and titanium plus 3, which one will be more stable and why? The titanium plus 4, because titanium plus 4 has a noble gas electronic configuration. So why it has a noble gas configuration? Because in its valence shell, it has completely filled electrons. That is why it has a noble gas electronic configuration, and it is having a argon 18 electronic configuration, or you can say that it is Ns2np6 configuration. That indicates that in its valence shell, all the electrons are completely filled. Because of this, titanium plus 4 oxidation state, it is more stable than that of the titanium plus 3. Next question. The transition element shows the catalytic property. Give the 2 reasons for that, or they can ask you to write for the 3 reasons also. So, you must know that why that transition elements which also shows the catalytic property. So, we all know that the D block elements, or the transition elements, frequently they are used as a catalyst for most of the reactions. Okay, that is one of the interesting characteristics of these blocks. Due to the variable oxidation state, the largest surface area for the absorption of the reactant and formation of the intermediate compound. So, during the chemical reactions, this catalyst will provide the largest surface area for the absorption of the reactant molecule, and during the reactions, it forms an intermediate product, and also due to the variable oxidation state, this transition elements blocks, they act as a very good catalyst. Next question. Explain the manufacturing of potassium dichromate from the chromite ore. So, which is the most frequently asked question for the 3 marks. Okay, definitely these questions will be asked, or with the potassium permanganate can also be asked. Most of the time potassium dichromate which has been asked. Coming to this question, you need to write the 3 steps to indicate that how potassium dichromate which has been formed. So, here in detail I have explained. So, in the examination with the balanced chemical equation, if you write, it's enough to get a 3 mark. Okay. In the first step, the chromite ore which has been fused with a sodium carbonate in presence of an air to get a sodium chromate. So, in the first step what we are taking? We are taking the chromite ore. Okay. So, it is nothing but a chromite ore which has been treated with the sodium carbonate in presence of an air. It gives rise to the sodium chromate with the formation of iron oxide with the release of carbon dioxide. In the second step, this sodium chromate, which is a yellow solutions which has been treated with the sulfuric acid, which will be undergo acidification and give rise to the sodium dichromate with the formation of sodium sulfate and water. In the third step, the sodium dichromate will be further treated with the KCl, that is potassium chloride, to form a potassium dichromate. So, in the examination, step 1, step 2 and step 3 reactions if you write, it's enough to get a 3 marks. And if you know how to write it in your own words, you can write it. But please see that if you miss the 4 or 8 with the 7, so you can't get the marks. Okay, it's necessary to balance the equation. Okay, next question. How is potassium permanganate is prepared from MnO2? Write the equations. So again, if they don't ask the potassium dichromate, definitely they are going to ask with the potassium permanganate. Okay, please go through with these 2 reaction practice well, and you will get a 3 marks very easily from this D block groups. Okay. Potassium permanganate is prepared by fusing the fusion of manganese oxide with a potassium hydroxide in presence of an oxygen to give a formation of potassium magnetite. Potassium magnetite. This fusion mass is extracted within water, or later that will be treated with or acidified with H2SO4 to give a potassium permanganate with the manganese dioxide and potassium sulfate will be formed. Either you can show this reaction by showing the acidification, or you can directly show it with the H2SO4. In the next step, commercially it is also prepared by the alkaline oxidative fusion of MnO2 followed by the electrolytic oxidation of magnetite. So, it will be fused to get a MnO4 2- and similarly MnO4 2- will be undergo electrolytic oxidation with an alkaline medium to give a purple color manganese oxide. Okay. So, in the examination if you write these 2 steps, it's enough to get a 3 marks. Okay. Hope you all understood with this unit. I'll come back with the next unit. Till that, take care, be safe. Thank you.